Let's do some practice questions on the sine, cosine, and tan. Here's a question. Here is a line which makes an angle alpha with the x-axis, and then a right angle triangle drawn with a right angle here. You have 3 centimeters on the base, 4 centimeters on the height. So the question is to find sine alpha, cos alpha, tan alpha. So the step 1, right, always write down your sides: opposite, adjacent, and hypotenuse. Okay, now for this angle here, what is the opposite side? This is your opposite side, right? And what is your adjacent side? The angle is here, so adjacent side should be here, right? What is the hypotenuse? Hypotenuse would be this, right? And then you can step 2 is to write down the formulas of whatever you want to find, right? For example, sine alpha, in this case it's alpha, right? It's what? Opposite over hypotenuse, right? Do you know what the hypotenuse is? No, they gave only the base and the height. But can you find the hypotenuse? Yes. How? By using the Pythagoras theorem, right? So Pythagoras theorem says that your hypotenuse is square root over your adjacent square plus opposite side square, right? What is your adjacent square? 3 square is 9, plus what is your opposite square? 4 square, 16. Square root of that, how much is it? Square root over 25. So your hypotenuse is 5 centimeters, right? So your hypotenuse would be 5 centimeters. So now how much is sine alpha? Opposite our hypotenuse. So how much is your hypotenuse? Your opposite? 4 centimeters. So it's 4 centimeters over hypotenuse is 5 centimeters. So sine alpha is 4 over 5, right? How about cos alpha? Cos alpha is given by your adjacent or hypotenuse, right? What is your adjacent side? 3 centimeters. So 3 over, what is your hypotenuse? It's 5. So 3 over 5 is your cos alpha. Now let's find tan. Tan alpha is defined by opposite over adjacent. How much is your opposite? 4 centimeters. So 4 over, how much is adjacent? 3 centimeters. So 4 over 3. So this is how you find the values of sine, cosine, and tangent, right? First step is to write what are the opposite, adjacent, hypotenuse sides, and then put your definitions and then find each one of them. And don't forget the Pythagoras theorem. That is also a very good one where you can find your hypotenuse. Let's do one more example question. Let's do the next practice question. Find sine theta and tan theta for this right triangle here. So if you see, the angle is on the top here, theta, right? So step 1 is to write down where is your opposite, adjacent, and hypotenuse. So this is the angle here, right? So this would be your adjacent angle, right? So you would write down adjacent here, right? and this is your opposite. Since the angle is here, the opposite side is this, so this is opposite, and this is always your hypotenuse, right? Good. Now to find sine theta, you need write down the formula, right? Sine theta is opposite over hypotenuse. What is opposite? It's 8 centimeters. 8. What is hypotenuse? It's 10. 8 over 10, or you can write it as 4 or 5, right? Now tan theta, how do you define tan theta? Opposite over adjacent. You know what is opposite, right? Opposite 8. How about the adjacent? You don't know, but can you find it? Yes, using the Pythagoras theorem, right? Pythagoras theorem states that your hypotenuse square equal to your opposite square plus adjacent square, right? What is your hypotenuse? 10. So it's 10 square equal to what is your opposite? 8 square plus you need to find the adjacent, right? Adjacent square. So this is 100. If you bring the 8 square this side, it will become minus 64 equal to adjacent square. What is 100 minus 64? It's 36. So 36 equal to adjacent square. And so how much is the adjacent side length? It will be square root over 36 equal to 6. So your adjacent length would be 6 centimeters, right? If your hypotenuse is 10, your opposite is 8, your adjacent side would be 6 centimeters. Now let's come back and do the tan. So tan theta would be opposite. What is your opposite? 8 centimeters, and your adjacent is 6 centimeters. So this will be 4 over 3. So now you found sine theta, which is 4 over 5, and tan theta, which is 4 over 3, given this angle as theta.